Hello guys, in this project I have tried to do feature visualization of human activity recognition system using class activation maps. For this I have chosen the mHealth dataset, which has accelerometer sensor data collected from 10 volunteers performing 12 activities. This particular graph shows here the count plot of the dataset. Here we can see that the number of samples in the jump front and back class is very low compared to other classes. Thus I have removed the samples from this particular class in order to balance the dataset before training the model. The model used in this project is a very simple convolutional neural network. It has four one-dimensional convolutional layers followed by a global average pooling layer and then a dense activation layer. This graph here shows the accuracy and loss on the training and validation set. As you can see, the model is doing very good, and also the performance of the model on the test set is 94%. This here shows the confusion matrix on the test data. Here we can see that the model is doing very well in almost all classes except for standing and sitting class. It is getting confused between those classes, and this is again explained by the nature of the data itself. The next step was to plot the class activation map of the model. For this we extract the weight of the final layer and the feature map of the last convolution layer. The dot product of these weights and the feature maps gives us the class activation map. We then overlay the class activation map on the sample from the dataset to get heat map type plot with each data point signaling its contribution to the model's prediction. Here this graph shows a sample from the climbing stage class, and it has three axes x, y, and z for accelerometer data. And here we can see that the sharp rises in the dataset is contributing more towards the model's prediction. And the model is able to classify this sample into its correct class with probability of 0.99. Similarly, this is a sample from the cycling class, and here we can see that the rapid changes in the dataset is contributing more towards the model prediction. Similarly, a sample from a knees bending class, again a sample from running class, and again for running class the more rapid changes in the dataset is contributing more towards the model's prediction. We also have a sample from a sitting class, and finally a sample from a walking class. Thank you.